This video covers Notes 8.1, Correlation Coefficient and Reasonable Fit. So a scatter plot is a type of plot or diagram using points to display values for two variables. A linear trend line drawn without technology, or a regression drawn with technology, can be used to simplify data points that resemble a line. And then correlation tells us how two sets of data relate to one another. If there's correlation, then there's some sort of relationship. So using these pictures below, we're going to define what type of correlation is existing. So these right here, if you were to draw a line through them, that would be a negative slope, and this is a negative linear correlation. So they make a line that would be a negative line. So you could probably guess this one would be a positive linear correlation. Now this over here is no correlation because it does not go in a line or at all, and this is a non-linear correlation where it does not look like a line. And we're going to talk about things that are non-linear in the next semester. So the equation of a line can be written in slope-intercept form, which is y equals mx plus b, and the correlation coefficient is r. So in order to see the r value, we have to turn on our stat diagnostics. So over here on your calculator, you will need to click mode, so it's a top middle button, mode, scroll up 3 times, so up, 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 and then where it says stat diagnostics, you're going to turn it on. So you're going to scroll to the right and then click enter so that on is highlighted or bolded, and then click second quit. Now you won't see any immediate changes, but you will see it when we do our stat calc steps. So over here, or down at the bottom of your first page of notes, so basically the front page is just information. So in order to see the r value, or once we get it from the calculator, we need to know what it means. So the closer r is to 1 or -1, the better the fit. So this just shows you some graphs where if r is -1, it'll be basically a perfectly straight line. -0.8 is turning into a not perfect straight line. -0.5 is getting further away, and these, if you notice, perfect, strong, weak, and then 0 is no correlation. So 0 matches the graph up at the top. And then we start going to 1. So 1 or -1 are perfect, is just perfect positive or perfect negative. And then anything between 0 and 1 is either strong if it's close to 1 or weak if it's further from 1. So we have some ones that we're going to go through. So the table shows the heights and lengths of several parallelograms. What does a correlation coefficient, so that's the r value, what does that for the data indicate about the strength of the heights and lengths? So we're going to go ahead and put this into stat edit. You should have these steps pretty well down pat at this point. So x's or height in L1, y's or length in L2. From here, we're going to click stat, scroll to calc, option 4. And we're going to add 2 things. First, we've already added the stat diagnostics. The second thing, before hitting enter all the way down, where it says store your regression equation, I need you to hit variables, scroll to y variables, enter, enter. Okay, so when we store, and we're not necessarily going to need it for all of them, but we're going to get in the habit, you're going to click variables, right, enter, enter, and you'll see why we want to do that on the second one. So with this one, we're going to click calculate, and this r value is what's new. That's what we turned on up here with the stat diagnostics. So down here, we are asked to talk about the r value. So the r value is -0.87. So I can see from the negative that there's no way A or B could be my answers because it is not positive. Now we just need to talk about -0.87. Is that strong because it's close to -1, or is it weak because it's closer to 0? So this one is going to be strong because -0.87 is pretty close to 1. Think about 87 cents off of $1. You basically almost have $1. Now you don't quite have $1, but you're very close to it. So we're going to go ahead and call that strong. This next one asks us to use the table between weight of a panda and its age. The data appears to follow a positive relationship, and it looks pretty strong. If you look at these dots over here, these are pretty close to a straight line, so positive, strong correlation. Then they ask us to use the regression to find the line of best fit and then determine the weight of a 7-month-old panda. So I'm going to go to stat edit the X is in L1, and remember this is a video so you can pause it if you need. Y is in L2. So I have my table in there. Pause if you need. I'm going to hit stat calc 4. For store, I'm going to hit variables right inner. And then I can look, my R value is 0.997, so that is very close to 1, so we were right about it being a positive strong. And then our equation is going to look really ugly, so we're just going to round to one number after the decimal, 5.1x minus 3.2. Now here's what we did, and we haven't seen it yet, but when you store this equation, what this does is it takes these really ugly decimals, and when you click y equals, it puts them in there. So if you notice, this is that really ugly slope, and it'll stop it when it needs to, your x value, and then minus your really ugly y-intercept. So it has taken all of these, when we did this, it's taken all of these really ugly decimals and put them into y equals for you, so you don't have to worry about rounding and getting slightly different answers. From here, they want to know the weight of a 7-month-old panda, so we've put our ugly answers in here. I'm going to go to the table. Weight is a y value, so they are giving us an x. At 7 months old, it would be about 32.5 pounds. So again, when you store that equation, it will put it in y equals for you, ugly decimals and all, so that you don't have to worry about typing those back in. Last one. We have a table between the lengths and weights of sand sharks. So again, stat edit. Remember, if you need to clear out your list, you clear the list. We do not delete the list, because if you delete, they disappear forever. And if you need to pause to catch up, that's fine. I'm going to hit stat calc 4 enter, store my equation, so variables right enter, scroll down to calculate, and that R value, this is a very strong positive correlation, so my equation I can round because I've stored it, so 4.4x minus 156.1, sorry. And then when you go to y equals, it has that really ugly equation there for you. We're going to go to the table, and then 75 inches is a length. They want the expected weight. So remember, you can scroll to 75, or you can change your table set. So second table set, you can tell your table to ask you for an x value. So when you go back to the table, it's empty, and when you type in an x value, it will tell you the y value instead of having to scroll to 75. Now, scrolling to 75 isn't that crazy. When we're talking about like scrolling to 2000, you would definitely want to go second table set. Now, if you want to put it back, you just go to where auto is highlighted and your table will fill back in for you.